June 6, 1944, at precisely 6:15 a.m., a young German soldier named Heinrich Severloh positioned himself behind his MG42 machine gun. From his concrete bunker perched on the bluffs above Omaha Beach, he commanded a clear view of the shoreline below. The morning air carried the scent of salt mixed with diesel fumes from the Armada gathering offshore. A thin fog still clung to the waters of the English Channel. Severloh was just 20 years old. 2 years earlier, he'd been drafted from his family's farm in Lower Saxony. Though trained as an artilleryman, fate had assigned him to this infantry position on the Normandy coastline. His hands remained steady as he performed his final checks. Ammunition belt loaded, barrel secured, sights aligned on the waterline. During training, he'd fired countless practice rounds. He'd never aimed at another human being. Hidden in the pre-dawn darkness below, the most massive invasion fleet ever assembled was approaching. Over 5,000 vessels, 11,000 aircraft, and 156,000 troops comprised the Allied forces attempting the most audacious amphibious assault in military history. Severloh's position bore the designation Widerstandsnest 62, Resistance Nest 62. The Germans had engineered these concrete fortifications into the coastal bluffs, specifically to create overlapping fields of fire. Their purpose was singular: transform any beach landing into a massacre. From approximately 40 meters above sea level, Severloh's bunker offered unobstructed firing lanes across nearly 2,000 meters of exposed sand on Omaha Beach's eastern section. His weapon was loaded with belted 7.92 millimeters ammunition, the standard German infantry cartridge that the Wehrmacht had employed since the turn of the century. Metal boxes stacked beside his position contained thousands of additional rounds. His assistant gunner stood ready to feed belt after belt into the weapon's hungry mechanism. As dawn broke, landing craft materialized from the gray sea, ghostly shapes emerging from the mist. The drone of their engines mixed with waves crashing against the shore. Through his binoculars, Severloh observed the craft drawing closer. Packed inside, he could see soldiers standing in tight rows, waiting for the ramps to drop. Around 6:30 a.m., the first ramps fell. American soldiers poured into the surf, each man burdened with 60 pounds of equipment. They struggled through water that often reached their chests. They were completely exposed. No cover existed on the beach, no protection from the guns positioned above. Severloh squeezed the trigger. The MG42 erupted with its characteristic sound, a sustained tearing roar unlike any other battlefield weapon. At 1,200 rounds per minute, individual shots were impossible to distinguish. The gun simply screamed continuously. What transpired over the following 9 hours would earn Severloh the grim nickname, the Beast of Omaha. But the weapon that made such devastation possible had a story beginning years earlier in a factory that had nothing to do with warfare. The MG42 wasn't designed by weapons experts or built by a prestigious arms manufacturer with generations of experience. It was created by mechanical engineers who knew virtually nothing about machine guns, working for a company whose primary product was sheet metal lanterns. The factory was located in a provincial Saxon town most Germans had never heard of. The lead designer had never fired a weapon in combat. He'd never served in the military. His expertise lay in manufacturing processes, not in killing. Yet his creation became the template for nearly every general-purpose machine gun that followed, including weapons still in service with armies worldwide today, more than 80 years after its battlefield debut. This is the story of how a manufacturing innovation that saved roughly $100 per weapon transformed the way wars are fought. This is the story of the MG42. The challenge began with the MG34. In 1934, the German military introduced what they termed the Einheitsmaschinengewehr, the universal machine gun. The concept represented a revolutionary departure from existing doctrine. Previous military thinking maintained strict separations between different machine gun categories. Light machine guns were portable weapons carried by infantry squads for mobile warfare. Heavy machine guns were crew-served weapons mounted on tripods for sustained fire from static positions. aircraft machine guns featured specialized designs optimized for aerial combat. Anti-aircraft guns had their own unique requirements. German planners proposed something radically different: a single weapon capable of serving all these roles. One gun that infantry could carry with a bipod, mount on a tripod for sustained fire, install in vehicles and aircraft, and employ for anti-aircraft defense. One design meant one training program and one logistics chain. The result was the Maskeningewehre 34, the MG42. At the time of its introduction, it was arguably the world's most advanced automatic weapon. The MG42 was an air-cooled, recoil-operated weapon chambered for the standard German 7.92 by 57 mm Mauser cartridge. It fired at approximately 850 rounds per minute, significantly faster than comparable British or American machine guns. It fed from 50-round belts that could be linked together for sustained fire, or from 75-round saddle drum magazines for mobile operations. The weapon featured a quick-change barrel system. A trained gunner could swap barrels in under 15 seconds, allowing sustained fire without overheating. The sights were adjustable for range and windage. The trigger mechanism permitted both semi-automatic and fully automatic fire. Most importantly, the MG42 could adapt to multiple roles through different mounting systems. On its integral bipod, it functioned as a light machine gun. On the Lafette tripod, it became a medium machine gun capable of accurate fire at ranges exceeding 1,000 meters. Special mounts allowed installation in tanks, armored vehicles, and aircraft. The German military took pride in the MG42. They believed it gave them a significant advantage over potential adversaries. In many respects, they were correct. But the MG42 harbored a critical flaw that wouldn't become apparent until Germany began preparing for major war. The weapon was extraordinarily difficult to manufacture. The MG42 was a machinist's weapon. Nearly every component required precision machining from solid steel billets. The receiver was milled from a single block of high-grade steel. The bolt assembly contained dozens of precisely fitted parts. The barrel extension, the feed mechanism, the trigger group, all demanded the attention of skilled craftsmen using expensive machine tools. Each MG42 required approximately 150 man-hours to manufacture. That meant a single worker operating full-time could produce perhaps one weapon per month. In practice, production was divided among specialists at different stages, but the total labor investment remained unchanged. The cost was 327 Reichsmarks per unit, roughly equivalent to $130 American at contemporary exchange rates. To put that in perspective, an average German factory worker earned approximately 150 Reichsmarks per month. A single MG42 cost more than 2 months of an ordinary worker's wages. The weapon also required 49 kilograms of raw materials, primarily high-grade steel alloys containing metals Germany had to import. As political tensions escalated through the late 1930s, access to those materials grew increasingly uncertain. Most critically, the MG42 demanded skilled labor that was in short supply. Germany possessed excellent machinists and toolmakers, but their numbers were finite. Every machinist working on MG34s was a machinist not working on aircraft engines, tank components, artillery pieces, or the 1,000 other precision parts that modern military equipment required. The Wehrmacht recognized the problem. Staff planners calculated their machine gun requirements and compared them to production capacity. The numbers didn't match. Germany couldn't manufacture enough MG34s to equip the army they were building. In February 1937, the German Army Weapons Agency issued a request for proposals. They wanted a new universal machine gun that could match the MG34's combat performance while being significantly easier and less expensive to produce. 3 companies received development contracts. 2 were obvious choices. Rheinmetall Borsig of Dusseldorf was one of Germany's premier weapons manufacturers. The company had been building military equipment since the 19th century. They possessed extensive experience with machine guns, artillery, and armored vehicles. They had the engineering talent, the production facilities, and the institutional knowledge to develop a new weapon. Stubgen of Erfurt was another established arms maker. They'd produced military equipment for decades and maintained strong relationships with the German military procurement system. The third company was unexpected. Metal und Lackierwarenfabrik Johannes Grossfuss was located in Dobeln, a small Saxon town with a population of roughly 20,000 people. The company name translated to Metal and Lacquerware Factory Johannes Grossfuss. Their primary business was manufacturing pressed and stamped sheet metal components. Their signature product was lanterns. They'd never designed a weapon of any kind. They had no experience with military contracts. They had no reputation in the arms industry. What they did have was expertise in a manufacturing process that the weapons companies had largely ignored. They knew how to stamp metal. The man tasked with leading their machine gun project was Dr. Werner Gruner. He was 33 years old, a mechanical engineer who specialized in mass production techniques. Gruner had been born on June 7, 1904, in the village of Topeln, a tiny community that would eventually be absorbed into the town of Kolditz. Gruner's father was a schoolteacher. The family wasn't wealthy, but they valued education. Young Werner showed early aptitude for technical subjects. He attended the Real Gymnasium in Dobeln, a secondary school emphasizing mathematics and science. In 1923, he completed his secondary education in Leipzig and enrolled at the Technical University of Dresden. He studied mechanical engineering from 1923 to 1928, focusing on manufacturing processes and production efficiency. He completed his doctorate and remained at the university as a research assistant for 2 more years, deepening his expertise in mass production techniques. In 1930, he joined Grossfuss as a technical designer. Gruner knew nothing about weapons. He'd never served in the military. He'd never fired a machine gun. His expertise was in stamping sheet metal into useful shapes using hydraulic presses and simple tooling. This apparent disadvantage would prove to be his greatest asset. The other 2 companies approached the problem like weapons designers. They attempted to improve upon existing designs, to refine and optimize the mechanisms that had worked in previous machine guns. They focused on ballistics, metallurgy, and combat performance. They assumed that a machine gun had to be built using traditional methods, with machine parts made from solid steel. Gruner approached the problem like a manufacturing engineer. He asked a different question. Instead of asking how to make a better machine gun, he asked how to make a machine gun better suited to mass production. Before beginning his design work, Gruner made an unconventional decision. He enrolled in a German military machine gun course. For several weeks, he trained alongside soldiers, learning to operate the MG42. He fired thousands of rounds. He learned how gunners carried their weapons, how they set up firing positions, how they fed ammunition belts, how they changed overheated barrels. He paid attention to things that traditional weapons designers might overlook. How did soldiers maintain their weapons in the field? What parts broke most often? What procedures took too long? What could go wrong during combat? He talked to experienced gunners about their frustrations with the MG42. They told him about sensitivity to dirt and dust. They complained about parts that were difficult to replace. They described situations where the weapon had failed them when they needed it most. Then Gruner returned to Dobeln and started designing from first principles. Traditional machine guns used precisely machined parts made from solid steel billets. A skilled machinist would start with a block of high-grade steel and carefully remove material until the desired shape emerged. The process was slow, expensive, and required craftsmen at every stage. It also wasted enormous amounts of steel. Much of the original billet ended up as metal shavings on the machine shop floor. Gruner proposed something radical. He would build a machine gun primarily from stamped sheet metal components, the same techniques Grossfuss used to make lanterns. Sheet metal stamping worked differently than machining. Instead of removing material from a solid block, stamping pressed flat sheets of metal into 3-dimensional shapes using hardened steel dies. The process was fast. A hydraulic press could form complex shapes in seconds. The parts required minimal finishing. They could be produced by relatively unskilled workers following simple procedures. Stamped parts also used material more efficiently. There was little waste. A flat sheet went in, a finished component came out. Nearly all the metal ended up in the final product. And stamped parts were surprisingly strong. The stamping process compressed and work-hardened the metal, increasing its strength. A properly designed stamp component could be stronger than a machined equivalent made from the same grade of steel. The weapons experts were skeptical. They believed that a stamped metal machine gun would be flimsy, unreliable, and prone to failure under the stress of rapid fire. They pointed out that the forces involved in automatic weapons were enormous. Thousands of pounds of pressure repeated hundreds of times per minute. Surely stamped sheet metal couldn't handle such abuse. Gruner set out to prove them wrong. Working with a small team that included a talented small arms designer named Kurt Horn, who had previously worked at Mauser, Gruner developed a new machine gun design built almost entirely from stamped steel. Only the most critical components, the barrel, the bolt, and a few other high-stress parts, would be machined from solid steel. Everything else would be stamped, pressed, riveted, and spot-welded. The design incorporated a unique operating mechanism. Instead of the rotating bolt used in the MG42, the new weapon used a roller locking system. 2 rollers in the bolt head engaged matching recesses in the barrel extension. When the weapon fired, gas pressure pushed the bolt rearward, but the rollers prevented it from opening until the bullet had left the barrel and pressure had dropped to safe levels. Then the rollers were cammed inward, unlocking the bolt to cycle and load the next round. The roller locking mechanism was elegant, reliable, and well-suited to stamp construction. It would later influence numerous other weapons designs. By October 1937, all 3 companies submitted their design proposals. Rheinmetall Borsig and Stubgen both offered gas-operated designs based on conventional machining approaches. Grossfuss submitted something completely different. The evaluation board examined all 3 proposals. They assessed performance specifications, manufacturing requirements, and projected costs. The decision wasn't close. The Grossfuss design was selected for further development. The lantern makers had beaten the established weapons manufacturers. The initial trials of the Grossfuss prototype in April 1938 revealed areas requiring improvement. The feed mechanism needed refinement. The barrel change system wasn't fast enough. Some components showed excessive wear during extended firing tests. Gruner and his team returned to the factory and addressed each issue systematically. They tested, modified, retested, and modified again. They kept the design deliberately similar to the MG42 in external appearance and handling characteristics. This was intentional. Soldiers familiar with the MG42 could transition to the new weapon with minimal retraining. The mounts, accessories, and support equipment already developed for the MG42 would work with the new gun. By February 1939, the improved prototype, designated the MG39, was ready for extended testing. The results exceeded all expectations. The stamped steel construction, which critics had predicted would fail, proved more robust than the precision-machined MG42. The new weapon was less sensitive to dirt, dust, and debris. It tolerated the kind of abuse that caused the temperamental MG42 to jam. It kept firing in conditions that stopped other machine guns cold. Tests in sand, mud, and extreme temperatures showed superior reliability. The stamped components flexed slightly under stress rather than cracking. The looser tolerances of stamp construction actually helped rather than hurt, allowing the mechanism to function even when fouled with debris. And the production numbers spoke for themselves. The MG42 required 150 man-hours to manufacture. The new Grossfuss design required 75, half the labor for the same firepower. The MG42 consumed 49 kilograms of raw materials per weapon. The new design used just 27.5 kilograms, nearly half the steel, freeing up strategic materials for other uses. The MG42 cost 327 Reichsmarks. The new weapon cost 250 Reichsmarks, a 24% cost reduction that would save millions as production scaled up. But those savings came with something else, something that would terrify Allied soldiers for the rest of the war. The new gun fired faster than any infantry weapon in existence. The MG-34's rate of fire was approximately 850 rounds per minute, already faster than Allied machine guns, which typically fired 450 to 600 rounds per minute. The Browning M1919 that American forces used fired at roughly 500 rounds per minute. The British Vickers was similar. The new Grossfuss design fired at 1,200 rounds per minute. Some variants would reach 1,500. This was deliberate. German tactical doctrine emphasized suppressive fire, the ability to keep enemy soldiers pinned down while assault troops maneuvered. Military analysts had studied combat footage and concluded that targets were typically exposed for only brief moments as soldiers moved between cover positions. Maximum bullet density during those brief windows was essential. A weapon firing at that blistering rate put twice as many bullets on target as one firing at 600 rounds per minute. The engineering challenges were immense. At 1,200 rounds per minute, the gun cycled 20 times per second. The bolt traveled back and forth faster than the human eye could follow. Enormous forces were generated and absorbed with each cycle. The barrel heated rapidly from the continuous friction of bullets passing through at high velocity. Gruner and his team solved each problem methodically. They designed a quick-change barrel system that allowed a trained gunner to swap barrels in under 6 seconds. A lever on the side of the receiver unlocked the barrel. The gunner wore an asbestos glove to grasp the hot barrel and pull it free. A fresh barrel slid into place and locked automatically. With practice, gunners could change barrels without interrupting their observation of the battlefield. They developed a feed mechanism that pulled ammunition belts smoothly and reliably at the extreme cycle rate. The feeding system used a roller-driven arm inside the receiver cover that moved back and forth with each cycle, advancing the belt one round at a time. The mechanism was so reliable and efficient that it became the template for numerous future designs. They engineered a weapon that could sustain fire rates that would have destroyed any previous machine gun. A limited production run of approximately 1,500 improved weapons, designated the MG39/41, was completed in 1941 for combat trials. German infantry units tested the weapons in actual combat conditions on the Eastern Front. The reports were enthusiastic. Soldiers loved the new gun. It was lighter than the MG34. It was more reliable. It was easier to maintain. And the rate of fire was devastating. In early 1942, the German military officially accepted the design for full production. Manufacturing contracts went to Grossfuss, Mauser, Gustloffwerke, Steyr, and others. The weapon entered production as the Maskeningewehre 42, the MG42. In May 1942, the MG42 saw its first significant combat action. The German Afrika Korps deployed the new weapon during the Battle of Gazala in Libya. British troops encountered something they'd never experienced before, a machine gun that sounded like nothing else on the battlefield. The human ear cannot distinguish individual shots at that cyclic rate. The brain cannot process 20 discrete sounds per second. Instead of the familiar rat-a-tat-tat of conventional machine guns, the MG42 produced a continuous tearing sound, like heavy fabric being ripped apart. British soldiers said it sounded like cloth ripping. Others compared it to a buzzsaw cutting through wood. The nicknames followed quickly. British troops called it the Spandau, a carryover from World War I when German machine guns had been manufactured in the Spandau district of Berlin. American soldiers called it Hitler's Buzzsaw. Soviet soldiers on the Eastern Front called it the Linoleum Ripper for the way the sound reminded them of flooring being torn up. German troops had their own names. They called it the Knochensige, the bone saw, for the damage it inflicted on human bodies. They called it the Hitlersige, Hitler's saw. They called it Die Singen Sage, the singing saw, for the distinctive pitch of its firing. By mid-1942, the MG42 was being deployed on all fronts. Production ramped up with impressive speed. German factories produced 17,915 MG42s in 1942, a partial year of production. That number jumped to 116,725 in 1943. In 1944, even as Allied bombing intensified, production peaked at 211,806 weapons. In the final months of the war, with Germany's industrial base collapsing, factories still managed to produce 61,877 MG42s in 1945. By the war's end, more than 400,000 MG42s had been manufactured. Despite the intention to replace the MG34 entirely, both weapons remained in production throughout the war. The MG34 continued to serve, particularly in roles where its ability to use drum magazines was useful. But the MG42 became the signature German infantry weapon of the conflict. The psychological impact on Allied soldiers was severe. The sound alone was terrifying. Nothing in their training had prepared them for a weapon that screamed continuously instead of chattering in bursts. Veterans later described the visceral fear that the sound induced, a gut-level reaction that was difficult to control through discipline alone. But the reality was worse than the sound suggested. At that blistering cyclic rate, a sustained engagement lasting 30 seconds put more than 600 bullets into the beaten zone. Against exposed infantry, the results were catastrophic. The weapon reshaped German infantry tactics. While American and British doctrine emphasized the individual rifleman as the primary infantry weapon with machine guns providing support, the Wehrmacht built its squads around the machine gunner. German tactics placed the MG42 at the center of every engagement. Riflemen served primarily to carry ammunition, protect the gun crew, and finish off enemies that the machine gun had suppressed. A typical MG42 crew consisted of 6 men. The gunner operated the weapon, controlling fire and selecting targets. The assistant gunner helped feed ammunition belts and watched for threats the gunner might miss. He was also trained to take over immediately if the gunner was killed or wounded. One soldier carried the Lafette tripod for sustained fire positions. 3 additional soldiers carried spare barrels, extra ammunition, tools, and other supplies. Every member of a German infantry squad understood that keeping the MG42 firing was their primary mission. The ammunition consumption was enormous. At 1,200 rounds per minute, a sustained engagement could burn through an entire squad's ammunition supply in minutes. German logistics devoted considerable resources to keeping MG42 positions supplied. Infantry units stockpiled ammunition at defensive positions. Resupply operations prioritized machine gun rounds above almost everything else. But the weapon delivered results that justified the consumption. In defensive positions, a single MG42 could dominate open ground for hundreds of meters in every direction. In offensive operations, the gun provided suppressive fire that pinned defenders in place while assault teams maneuvered to flanking positions. On the Eastern Front, where distances were vast and cover was often scarce, the MG42 proved particularly devastating. Soviet infantry attacks frequently ran into walls of automatic fire that shattered assault waves before they could close with German positions. Soviet soldiers learned to fear the distinctive sound. They developed tactics specifically designed to neutralize MG42 positions before attempting advances. At Monte Cassino in Italy, German defenders held the ancient monastery for nearly 4 months, from January to May 1944. American, British, Polish, and New Zealand troops attacked repeatedly. Each assault ran into MG42 fire from fortified positions in the hills above. The defenders swept entire approach routes with sustained fire, cutting down wave after wave of attackers. The Allied forces eventually resorted to massive aerial bombardment that reduced the monastery to rubble. Even then, German machine gunners continued fighting from the ruins. In the hedgerow country of Normandy, after D-Day, MG42 teams turned the thick bocage into killing grounds. The Norman hedgerows were ancient field boundaries, dense walls of vegetation growing on earthen banks that divided the countryside into a maze of small enclosed fields. The narrow gaps between hedgerows became natural kill zones. A single MG42 position at the end of a lane could halt an entire company's advance. American infantry learned to listen for the distinctive sound and take cover immediately when they heard it. The situation became serious enough that the United States War Department produced a training film specifically to address the psychological impact. War Department Film Bulletin Number 181, titled Automatic Weapons, American vs. German, was released in 1944. The film was designed to help soldiers cope with the fear that the MG42 induced. The narrator acknowledged that American soldiers were intimidated by the MG42 sound. He showed footage of the German weapon firing, then demonstrated American machine guns for comparison. He assured viewers that the German gun's bark was worse than its bite. He explained that American weapons, though slower firing, were more accurate and more controllable. The film included a dramatized sequence showing a green replacement soldier cowering under MG42 fire, while his more experienced comrades remained calm. The message was clear. Fear of the sound was a rookie mistake. Experienced soldiers knew better. The narrator concluded with the reassurance that American weapons were superior. "The German gun is good," he said, "but ours is better." Historians later noted that the film was more propaganda than training material. The claims about American weapons being more accurate were questionable at best. The suggestion that the MG42's high rate of fire made it less dangerous was simply wrong. The reality was that the MG42's bite was devastating. Tens of thousands of Allied soldiers were killed or wounded by the weapon during the war. The MG3 has been produced under license by Italy, Greece, Iran, Pakistan, Spain, Turkey, and other nations. Over 1 million units have been manufactured worldwide. More than 40 countries have used variants of the MG42/MG3 design. In the 21st century, over 80 years after Gruner and his team submitted their stamped metal prototype, weapons descended from their design remain in active military service worldwide. The German Bundeswehr used the MG3 as its standard general-purpose machine gun until it began replacement with a Heckler & Koch MG5 in the 2020s. Turkish forces have deployed MG3 variants in operations against Kurdish militants. Pakistani troops have carried the weapon along the border with Afghanistan. Iranian forces used MG3s during the Iran-Iraq War of the 1980s. Spanish peacekeepers brought MG3s to the Balkans. Greek soldiers maintain MG3s in their arsenals today. The weapon that terrified Allied soldiers on D-Day continues to serve 8 decades later. Few military designs have proven so enduring. Werner Gruner survived the war. He remained in Germany, eventually settling in Dresden in the Soviet occupation zone that became East Germany. His expertise in manufacturing engineering was valuable to the communist government. Gruner became a professor at the Technical University of Dresden, where he'd studied as a young man. He rose through the academic ranks, eventually serving as rector of the university from 1958 to 1968. He trained a new generation of engineers in the manufacturing techniques he had developed before and during the war. He received numerous honors from the East German government. The Patriotic Order of Merit in 1959, the National Prize of the German Democratic Republic Second Class in 1961, the Order of the Banner of Labor in 1969. He was named Honorary Senator of the Technical University of Dresden in 1979. Werner Gruner died in Dresden on June 29, 1995, at the age of 91. He was buried in the Waldfriedhof-Weißer Hirsch Cemetery in the Loschwitz district of the city. His obituaries mentioned his academic career and his contributions to manufacturing technology. They noted his service as rector of a major technical university. They did not dwell on the weapon that had killed tens of thousands of Allied soldiers and established principles still used in firearms designed today. Heinrich Severloh also survived the war. He was captured by American forces shortly after D-Day and spent time as a prisoner of war. He was released after the German surrender and returned to civilian life, working as a farmer in northern Germany. For decades, Severlow did not speak publicly about his experiences at Omaha Beach. The memories haunted him. He had nightmares about the men he had killed. He wondered whether he was a war criminal, whether he had committed atrocity by firing so many rounds at soldiers who had no chance to fight back. He struggled to reconcile what he had done with his understanding of himself as a decent person. In 1963, Severlow read the book The Longest Day by Cornelius Ryan. In it, he found the account of David Silva, a 19-year-old American infantryman with the 29th Infantry Division who had been shot 3 times in the chest while landing on Easy Red Sector of Omaha Beach. Silva had survived his wounds. After the war, he studied theology and was ordained a Catholic priest in 1954. By the early 1960s, he was serving as a military chaplain stationed in Kaiserslautern, Germany. Severlow tracked him down and arranged a meeting. The 2 men who had been enemies on that bloody morning finally came face to face. They shook hands. They talked about the war, about their experiences that day, about the years that followed. They found a measure of peace in acknowledging each other's humanity. They recognized that both had been young men caught up in forces beyond their control. Severlow eventually published a memoir about his experiences titled WN62. Erinnerungen an Omaha Beach, Normandy, 6. June 1944 inch, WN62. Memories of Omaha Beach, Normandy, June 6, 1944. The book was published in 2000, when Severlow was 76 years old. In it, he wrote with stark honesty about what he had done and the burden had placed on his conscience for more than 5 decades. He met with American veterans on several occasions in the years that followed. Some encounters were difficult. Men who had lost friends or brothers on Omaha Beach struggled to extend forgiveness to the man behind the gun. Others were able to separate the young soldier following orders from the elderly man seeking reconciliation. One American veteran told Severlow that he understood that war makes killers of ordinary men, and that both of them had been victims of forces larger than themselves. Severlow died on January 14, 2006, at the age of 79. His obituaries described him as both perpetrator and victim, a man who had performed his duty with devastating effectiveness and spent the remainder of his life trying to atone for it. The MG42 itself stands as a monument to an uncomfortable truth about human ingenuity. Our most brilliant innovations often serve our darkest purposes. Werner Gruner's genius lay not in understanding death, but in understanding manufacturing. He approached the machine gun as an engineering problem to be solved through clever application of industrial processes. He succeeded brilliantly. His stamped metal construction revolutionized weapons production and influenced military small arms designed for generations. Yet his innovation's primary function was killing human beings as efficiently as possible. The 400,000 MG42s produced during the war, combined with millions more derivatives in the decade since, have been responsible for hundreds of thousands of deaths. The weapon extended wars, increased casualties, and intensified the horror of combat. It was, by any measure, extraordinarily good at its intended purpose. The story of the MG42 is ultimately a story about choices. Gruner chose to apply his considerable talents to a weapons project when he could have remained in civilian manufacturing. German military planners chose to prioritize weapons production efficiency over virtually every other consideration. Severlow chose to pull the trigger thousands of times on a June morning in 1944, though he was haunted by that choice for the rest of his life. Yet it's also a story about circumstances and systems that constrain individual choices. Gruner lived in a totalitarian state preparing for war. Refusing the assignment might have had severe consequences. Severlow was a conscripted soldier in a concrete bunker with enemy forces landing on the beach below. His range of choices was vanishingly small in that moment. The technical excellence of the MG42 is undeniable. The weapon represented a genuine breakthrough in manufacturing, methodology, and mechanical design. Gruner's insight that stamped components could replace machined parts in military weapons was revolutionary. His roller-locking bolt system was elegant and effective. His feed mechanism was a masterpiece of reliability. From a pure engineering perspective, the MG42 deserves its reputation as one of the most significant firearms designs of the 20th century. But engineering excellence divorced from ethical consideration produces the gas chamber alongside the machine gun, the atomic bomb alongside the microchip, the surveillance state alongside the internet. The MG42 forces us to confront the uncomfortable reality that human brilliance and human cruelty are not opposites but complements, that our capacity for innovation amplifies whatever purposes we choose to serve. Today, when military historians discuss the MG42, they focus on its technical specifications, its combat effectiveness, its influence on subsequent designs. These discussions are valuable and necessary. Understanding how weapons work and why they succeed or fail is crucial for military professionals and historians alike. But perhaps the more important story is the one about the young farmer from Lower Saxony who stood behind the gun, and the engineer from a small Saxon town who designed it, and the thousands of young men on both sides who died because the combination of those two people and that weapon happened to converge on a beach in Normandy on a June morning in 1944. The MG42 was extraordinarily successful. It achieved everything its designers intended. It gave Germany a decisive tactical advantage in many engagements. It influenced military doctrine and weapons design for generations. It remains in service after 8 decades. And it killed tens of thousands of people. Young men mostly, soldiers following orders, fathers and sons and brothers who never came home. That, too, is part of the story. Perhaps it should be the part we remember most.